But people have, did pretty well on the assignment. People that worked in the, pretty much, most people did. You got a lot of right answers, and there was a couple of things that people didn't do well, like the piecewise function and stuff like that. Okay. And some of that is stuff that we didn't get to go over because of the snow days. So we want to make sure that we understand slopes of straight lines very thoroughly when we do it today. And then I think I'm going to change the deadline for the assignment. So if you want to go back and do some of the stuff you missed, I think you'd be able to. Right. Although, you know, most people make fairly decent scores in this, you want to be sure you understand this because it's critically important. Okay, so we're trying to find the x-intercepts and sketch this graph. X-intercept occurs when y equals 0. Y-intercept occurs, of course, x equals 0. So once I wrote down this, hopefully that would be obvious. I'm pretty sure I did that in class. Unfortunately, I'm doing the same stuff right now in 3 different classes: intermediate algebra, the support course, and this course. So if I get a little confused about what I think I did, straighten me out. And I'm going to do everything pretty thoroughly. All right. So this ought to all be familiar. Let's see. I think last Tuesday I tried to anticipate that we're going to miss class and go over as much of this as we could. All right. So we got x-intercept, we got y-intercept. You got to know this. When you find intercepts, this is where you start. The x-intercept occurs on the x-axis, and on the x-axis, y is 0, right? And the y-intercept is on the y-axis. And the y-axis where x equals 0. Okay, so we have the equation, negative 4x plus 6y equals 24. X-intercept, we'll let y equals 0. All that, the 3 dots mean we go through the steps of solving this very simple equation. Everybody knows how to solve it, okay? 6 times 0 is 0, so we have negative 4x equals 24. Divide both sides by negative 4, you get x equals negative 6. Okay, y-intercept. Okay, then. Okay, one common thing that people do with intercepts that you just can't ever do, but a lot of people do it, 70%. So we want to be sure we don't do this. And what we do is, once we've got one of the intercepts, we know that x is negative 6 when y equals 0, right? That gives us a point on the graph. The x-intercept is negative 6, 0. Okay. How do we know that? Because we let y equals 0 to find out what x is when y equals 0. Okay. Then we can check it. We can plug negative 6 in for x and 0 for y. And we see negative 4 times negative 6 is 24. 6 times 0 is 0. That's a negative 24. Negative 4 times negative 6 is 24. 6 times 0 is 0, so we get 24 equals 24. There it is. So you check. Keep emphasizing, check every step, because if you're doing a step wrong, you're going to discover it. And then you're very likely, because you're doing pretty well here, you're very likely to figure out what it was and learn it much better than if you just give it to open math and open math says, nope. Not only do you lose points, but you've failed to catch yourself in an error, which is maybe the best thing you can do for learning. Doesn't mean you go around intentionally making errors to learn. Check. So the process. Start with one of the intercepts, x or y. What the equation tells you, and write down, here's your intercept. Okay. Then the y-intercept. You're going to let x equals 0. So you're going to have negative 4 times 0 plus 6y equals 24. Y equals 4. So the y-intercept is 0, 4. Is that true? Okay. It's a very simple process. And you have to know this because you're going to be finding intercepts and functions for the rest of the course and throughout subsequent math courses, okay? You want to lock in what it means to have an x-intercept, what it means to have a y-intercept. X-intercept occurs on the x-axis, y is 0, etc. Okay? Common mistake. People get this and then say, okay, we have the point -6, 4. Okay? And I think many of you have done this, because I think I've seen it in all my classes in the last week, frequently. Okay? So think about what you're doing and why you're doing it. This says that when y is 0, x is -6. This says when x is 6, 0, y is 4. So we have this point and this point. We don't have the point -6, 4. -6, 4 doesn't have anything to do with the graph of this function. If we plug in -6 for x, we get 24. We plug in 4 for y, we get 24. 24 and 24 is 48, which doesn't equal 24. Understand what I just said? If you try to check out 6, -4, or -6, 4, it's not going to work. It doesn't satisfy the equation. Points that you get, the points that you graph, have to satisfy the equation. That's a very important concept. It's not a trivial concept. So think about it. Okay, anyhow, so now we find the slope. Well, how do we find the slope? There's a formula for slope. I don't recommend using the formula without drawing a picture. Because sometimes you can't draw the picture, you have to use a picture. Equals -6. Here's y equals 4. Here's the x-intercept. Here's the y-intercept. This is a straight line. You can recognize a straight line. You have just an x and a y term. No x times y, no x squared, no square root of y. Okay, nothing weird, just plain old multiple of x and y. And of course, I'm pointing over there. Okay. So now we draw a straight line. It's always easier if you have a picture to think about what you're doing. If you don't remember how to find the slope and then you draw the picture, you might well remember if you understand what slope is and if you've always drawn the picture to reinforce it. So when you get to the exam and have to find a slope and you forget what to do, okay, you have a picture that you're used to drawing. And again, I emphasize when you do your homework, write out everything, draw every picture, because that's how you remember. What I find on tests and exams is that people don't remember. Okay, they lose a lot of points. They don't remember. Partly because people don't seem to understand how much you need to review, partly because people don't typically, in an open math type assignment, write out everything. If they can do it on the computer and they get the right answer and haven't written it out, okay, yeah, you got the homework right, but you haven't written anything out, so you don't have as much. You need it. Okay, please write things out, write them out thoroughly, write out words so you understand the logic, so you understand what you're doing, you will understand the math much better, you perform much better, and you retain it much longer. Okay. So anyhow, you've seen these arrows, haven't you drawn these arrows in this class? How many of you have seen these arrows in the class? If you haven't, I need to explain. Okay, maybe I haven't, because Okay. Good question. How far do we have to go over? How far do we have to go up? Okay. If open math hasn't shown you something similar to this, there's a deficiency in the open math. Now, I chose the assignment, but I couldn't find anything anywhere in open math that emphasized the geometry of this situation. So we need to take a minute to do that. Okay, so we draw this picture. Now, this picture is, we start at the leftmost point, and we draw an arrow until we're right under the other. Okay, that tells us how far we've got to go over. And then we draw a vertical arrow, tells us how far we've got to go up or down. Now, how far up is what we call the rise. Now we can calculate it, but we can also see, I mean, if y is 4 here and y is 0 down here, we know we have to go up 4, right? But the calculation, just take this y coordinate and subtract this y coordinate. Okay, that's like your y2 minus y1 they give you in the formula. So that's the reason we just did y2 minus y1, but we're labeling it on a graph where we can see what it means. Then we do this arrow, which is to run. And the formula for that is x2 minus x1. We take this x coordinate and subtract this x coordinate. That's 0 minus -6 equals 6. Then we look at this picture and ask, does this make sense? Okay. It makes sense if we go over 6 and up 4 to get from the point -6, 0 to the point 0, 4. We have a picture. We see clearly that that makes sense. Okay. Then we complete this triangle. So that we've got this line that's on the line that we're graphing. And we say slope equals rise divided by run. Now, did you see anywhere in open math, did you see rise and run? Anybody see that? Some people are saying yes, some people are saying no. He saw a formula. He didn't say anything about what the formula meant then. Okay, so well, now you're seeing. So you want to draw this picture and you want to have this, the definition of the slope. How many have you ever seen slope equals rise divided by run in your prerequisite courses? That should be all over the place. Everybody should have seen that. And almost everybody, I believe, has. Every time I ask a class, if you, oh yeah, I recognize that. That's what slope is. Formula is the formula because slope is rise divided by run. The numerator of that formula is the rise. That's your y2 minus y1. The denominator is your run. That's your x2 minus x1. Okay, so a connection, and you should try to understand the formula in terms of the picture, and also understand how the picture represents the formula. But by all means, draw the picture if it's practical to do so. And don't just draw a line in open math using your mouse. Draw it out on your paper because it's a different experience and it sticks with you way better than using a mouse to create your line. Okay. And that's okay. I mean, it's good to do that, but only if you've actually drawn the picture, because then you get double reinforcement. Okay. So take a list. So this is how you graph the function, the linear function, by finding its intercepts. And you automatically sketch the graph and sketch that point. Sketch this arrow and this arrow so you know you go in the right direction. Now, notice if this arrow has to go down, if this point's lower, you're going to have a negative. Okay, because you got to go down. Up is positive, down is negative. I suggest you always go from left to right. Is that the way you read? That's the way you think. Okay. If you did go from right to left, then you'd have a negative run, wouldn't you? Because this would be going in the negative. This one in the positive direction, and then whether this one is up or down determines whether you have a positive or negative slope. All right. Find the equation of the line with the same slope through 5, 7. Okay. And I haven't finished the slope. It's rise divided by run, which is 4 divided by 6, which is 2/3. I put that 2/3 in a box so that I have a picture and I can immediately see what the slope is. And if I forget why I did the slope, I've written all this out to reinforce it, to make sure I remember it when I need it. Okay? It doesn't take long to write it out and it's worth the time. So everything is on the graph. Run, rise, slope, arrows indicating the run and the rise, etc. In the slope in a box so you can identify the slope without having to read everything else. Okay? Very handy to have the thing prominently displayed. All right. Now, got the line through 5, 7. The slope is 2/3. So how do you find a line through 5, 7 with a slope of 2/3? Go ahead and work on that if you haven't already. Many of you have. Line goes through 5, 7, the slope is 2/3. Now, there are 2 ways we can do this. And not everybody did it this way. There's actually an even better way, and some people did it that way, but I'm going to do it by just saying, what do we know? We know that the line is y equals mx plus b. M's the slope, so it's 2/3. So y equals 2/3 x plus b. Y equals 7. When x equals 5, and that's from this point here, tells us that y equals 7 when x equals 5. So 7 equals 2/3 of 5 plus b. We just plug the value of y and the value of x into this equation. Okay? And now we just solve for b. Now you can do fractions if you like, but I don't recommend it. As I've said again and again, you multiply out the denominator, you clear your denominator. You multiply both sides by a common denominator. There's only one denominator, that's 3, and that's your common denominator. So we have 3 times 7 equals 3 times everything here, right? Multiply this side by 3, this side just is 7, and multiply this side by 3, this side is 2/3 of 5 plus b. Now, one reason I think people don't follow my advice to multiply through by a common denominator is because it's hard for them to do this. To put a 3 in front of whatever's here and put a 3 in front of whatever's here, the parentheses, right? Because they're thinking, what am I going to do with that next? You don't think about what you're going to do next. You multiply both sides by the common denominator and you write it out literally. You don't worry about the next step until you get to the next step, okay? And I think what happens in a lot of cases is you're worried about what's going to happen next when you haven't done what you need to do, okay? So don't worry about what's going to happen next till now, and now we got to do what happens next, okay? Now you get to worry about it. Don't worry about it when you're doing this, okay? Well, we can multiply 3 times 7, and most people want to do that. You can delay that for a minute, but that's okay. But On the other side, we can't do a lot of calculations yet. We have to use the distributive law. Okay? Distributive law says that 3 times this mess, well, that 3 times this whole thing is 3 times this part plus 3 times this part, right? So if you just understand the distributive law, even if it looks weird to you, you're going to write 3 times 2/3 of 5. Okay, right there's 3 times this part plus 3 times this part. Well, this part should just be, so you get 3b. Okay. Now, some of you are still suffering by the fact that you learned fractions in 5th grade, then somebody put a calculator in your hand, you never had to do them again. Okay? Very, very bad design of the curriculum. You really need to know how to do fractions. That's why we started the course with an assignment on fractions. You might want to go back and review that. Okay? But what we do here is we multiply 3 times 2/3 times 5. Well, if you're insecure with fractions, you can multiply, right? This is 3/1 times 2/3 times 5/1. Then you've got 3b. You might not need to do that, but you should always be able to check yourself by doing it. Now, 3/1 times 2/3 times 5/1 is the same as 3/3 times 2/1 times 5/1. What did I do? I put this 3 where the 1 was, and I put the 1 where the 3 is. Why doesn't that make a difference? Because my denominators are still 1, 3, and 1. And when I multiply the denominators, I'm still going to get 3. Okay? I've got the same 3 denominators. Now 3 divides into the 3, leaving me the 2 and the 5. Simpler is to understand the rules for cancellation. You have to understand that 3 times 2 times 5 is a numerator, and 1 times 3 times 1 is a denominator, right? 3 is a factor of the denominator. It's something that's multiplied by the rest of the denominator. 3 is a factor of the numerator. Unfortunately, people often come out of their prerequisite courses not knowing what the word factor means. So when you have a rule that says you can divide a factor of the denominator into a factor of the numerator, right there, they don't understand it. They can do it for a day or two and then lose it, okay? So I'm saying this because you want to understand. I don't like to use cancellation because people, 2/3 of a class typically doesn't understand what cancellation is, okay? 1/3 understand it just fine. So, yeah, you could cancel this with this because this is a factor of the denominator. This is a factor of the numerator. If you can make that test and do it reliably, go ahead and cancel. I don't necessarily expect you to write it out like this, but I want you to try to understand what I'm telling you here. That the 3 does end up dividing the 3, and then you just have 2/1 times 5/5. So that's 1 times 2/1 times 5/1. I said 5, that was a mistake. Okay? So you can do all this stuff, and you're going to end up with, I'm in out of room here, but you get 21 equals 10 plus 3b. And you end up doing the rest of the solution. You get b equals 11/3. So here is what we need to put into the equation here. And now we have the equation for our graph, for our function. All I'm saying here is when you have this times this times this, make sure you understand how to multiply those things. Okay? The surest way is put 3/1 times 2 or 3 times 5/1. And you could multiply those out. Instead of doing everything I did here, you get 30 divided by 3, which is 10. Okay? So I'm going to erase what I did here, because it might be a little complicated for you. And erase this step and this step. At 21, these that multiply out to 30, these multiply out to 3. You get 21 equals 10 plus 3b, and the rest of the solution is very simple. You solve, you get subtract 10 from both sides, you get 11 equals 3b, you get b equals 11/3. Now, I'm not totally sure I did that right. I was talking about a lot of things. I think some people got 21/3 or something like that. Now, people I kind of pretty much trust to do things right, but nobody ever does everything right. So somebody's wrong. And maybe my memory seeing 21/3 is not 20. I wouldn't have seen 21/3 because you'd reduce that. So let's see if this really works. That's my whole point. Um, let's So what do I have? That should be the equation. Now, how do we test whether that's correct? Well, we let x equal 5 and see if we don't get 7. So we get y equals 2/3 of 5. Y should equal 7. Sorry. Well, you multiply that out, you get y equals 10/3 plus 11/3, which is 21/3, which is 7. Boom. So I actually did it right. Okay. Again, you need to be doing your own checks. Don't just trust the answer you get and wait for open math to tell you were wrong. Check it yourself. Takes a little longer, but you learn much more and you learn it much better. So homework is where you learn. And if you're chasing points rather than learning, in other words, getting the right answer by whatever method you can and getting your points, you're not going to learn it as well. Okay. Again, find the equation with a given slope through a given point. We can do this. Okay. We can write y equals mx plus b. We can write the slope. So we get this. And then we take the coordinates of the point, plug in here and solve for b. And then we get our equation. Okay. That's important. That's also important to understand that, okay, you could also say that like here, let's say here's the 0.57. Now I emphasize, and we should understand that this line lies on the line x equals 5 and on the line y equals 7. So here's the point. It's not here, it's not here. It's where these two lines intersect. At this point, x is 5. At this point, y is 7. The slope is 2/3. Well, let's say maybe the line looks like this. The slope of 2/3 is less than a slope of 1. Slope of 1 is at a 45-degree angle, so maybe 2/3 looks like that. Okay. Now, you don't try to do this on a very, very accurate graph. You're just drawing a graph to represent the situation so you have something to look at. Now, if x, y is a point on the line, then if you draw a path from this point to x, y, how far does it go here? Well, this distance would be x minus 5. This distance would be y minus 7. At least one person used the equation you get from this. Okay. Slope is, it's not y equals, it's 1 minus 7. Slope equals y minus 7 over x minus 5. So y minus 7 over x minus 5 equals the slope. Instead of the word slope, we'll use m because at this point, I think we understand that m is standard notation for slope. We're talking about straight lines, okay? And if m equals this, y minus 7 equals m times x minus 5. I believe that's given in open math as the point slope form for an equation. If you are fairly adept at doing this, you might want to understand this because this is a very simple reason why this is true. Okay. And again, if you can sketch this picture, you don't have to remember the formula. Although the formula is pretty easy to remember. Y minus y1 equals m times x minus x1, right? But it has a meaning. And there's a picture that goes with it. And I encourage you, I urge you, if you want to really master this stuff, to draw these pictures. Okay, whether you draw the picture or use the formula, though it's pretty easy to understand. In this case, the slope is 2/3. Again, we multiply both sides by 3 to get rid of the denominators. So we don't have to worry about fractions. So we get 3y minus 21 equals 2x minus 10. Well, we can add 21 to both sides. We can have 2x plus 11, divide both sides by 3. I don't have room. I'm just going to put 3 dots there, but that's very easy to solve. And you get y equals 2/3 x plus 11/3. The same thing you get if you use this method. Okay. you should be able to do it with either method because, and you know, I went through all this with this on the screen. So just quickly, just to review. Okay. Using this method, we say, okay, slope is 2/3, m is 2/3. We write y equals 2/3 x plus b. We pick, well, we take the point 5, 7. We replace y with 7, x with 5. We get this equation, which we solve for b. They're the details of solving the equation for b, and we went through those details. Then we get y equals mx plus b, with m equal 2/3 and b equals 11/3. We write that down. Here's the equation of our line. We check. We put in 5 for x and 7 for y. Put in 5 for x, there it is. Put in 7 for y, there it is. And we work out both sides. 2/3 of 5 is 10/3. We still have 11/3. 10/3 and 11/3. 10 and 11 is 21, so that's 21/3. So y equals 7, and that agrees. X equals 5, predicts that y equals 7. We know then that this equation is correct. And we have checked ourselves, so if we do make a mistake, we catch it ourselves and learn much more by correcting it. By just finding out later that it's wrong, we forgot everything we did. Okay? The other way to get this is with this picture, which was on the screen. So we worked through this idea that the rise is y minus, from 5, 7 to any point x, y, the rise is y minus 7, the run is x minus 5. So the slope is y minus 7 over x minus 5. We can write y minus 7 over x minus 5 equals m. We rearrange that, multiply both sides by the denominator, we get y minus 7 times x minus 5. Put in x equals m equals 2/3 and solve for y, and we get the same equation that we got here. Two different methods of getting the equation, they're both important. Okay. Okay, well, now we want to go on to finding the equation of a line through this point with this slope. I'm not going to write out the details of that. Because the details are exactly the same. We saw here. And through the point 6, -9. Slope of 2. Okay. I'll use this method, but next time I might use the other method. Okay. So I'm going to write out y minus -9 equals 2 times x minus 6. That's y plus 9 equals 2x minus 12 equals 2x minus 21. Plug in 6 for y. 2 times 6 is 12. 12 minus 21 is 9. Slope is 2 and point fits. So I've checked it. I didn't write out the check, but it's the same thing. Okay. And, you know, for good exercise, work it out this way and work it out the other way. You know, or we could say, or so we just do what we did before can be done in just a few steps. And it's identical to this. That's another way of checking it. We did it two ways. We got the same solution. And if we want to be really sure, we plug 6, -9 in and verify that it works. And numbers are simple this time, so it's real quick to do that. Okay. Again, I'm emphasizing check things. Check your work. You learn more that way. Okay. Now, we want to graph that equation. Get to point 6, -9. In other words, this point here. So x equals 6 is going to be there. I'm going to put y equals -9 here. What? My slope is 2/3. Can I get another point in this line? What's the y-intercept? I get the x-intercept or the y-intercept, right? In fact, let's just go ahead and get them both. Now, I'm not going to write it out. How do we get the x-intercept? We let y equals 0. Right? Gives us 2x minus 21 equals 0. So x equals 10.5. That can't be right. Makes the line way too steep. And the y-intercept, of course, is at -21. Okay. So we got like 0, -21. Our graph, goes through here. Okay, yeah, I'm looking at the wrong number. X-intercept is 10.5, 0. Now I'm leading up to something else. I'm just going to do these lines pretty quickly. Then find the equation of a line through 3, -2, and 12, -6. Okay, well, 3, -2. We want x equal 3. We want y equal -2. That would be maybe about here. And then, where is it? 12, -6. Well, there's 10.5. X is 10.5. X is 12 about here. Y equals -6. So now we have E line. Make sense? What's the equation of the line? Well, this equation is y equals 2x minus 21. This one, I'm just going to scratch it down here, is y minus -6. Have to do something else. First, I got to find the slope of this line. Slope, we go right, we got to go down. Rise is from -2 to -6, which is -4. Run is from 3 to 12, which is 9. Slope is -4/9. I haven't written out all the details of those steps and the logic, but I did that in previous problems, so you can see how that goes. Now we know Okay, if we've got 2 points, we can always find the slope, in other words, right? So we know the slope of the line. Um, I'm through 3, -2, and 12, -6. Slope equals -4/9. And then we can say y minus -2 equals -4/9 times x minus 3. If I do the arithmetic, I think I get y equals -4/9 x. And then get -4/3, which I'm going to add to 2, which is 6/3. I think plus 10/3. I'm going to put a question mark there, and I'll check it real quick. 48/9 is that, and that's 9, 9 1/3, 5 1/3, added to 3 1/3 is -2. Yeah, I think that checks. I did that in my head. I could be wrong. Okay, so here we have 2 lines. Okay. Now there are 2 things we can do with these 2 lines. The question is, where do the lines intersect? You have questions in that homework assignment that ask you to find where the 2 lines intersect. Find it algebraically. Okay. You've had the problem. Couple of ways to find the intersection. One, if you don't need to have a real precise result, is you can draw the graph and estimate. Well, you should always draw the graph of the 2 functions. Okay. And estimate the coordinates of this point. Well, y is -2 here, it's -6 here. Looks like it's maybe -4.5 here. Between -2 and -6, a little closer to -6. X is between 6 and 12. Here's 6, here's 12, closer to 6. I'm going to say intersection is maybe at 8, -4.5. Okay, we can check that. Put in 8. -4/9 of 8 is -32/9, about 3.5. Add that to 3 1/3 and get something close to 0, so it doesn't look like it works. But make sure I'm looking at my graph correctly. 8, -4.5. If this is 8, then y is -5. This is 8. This close to 4. -4 doesn't seem to work. maybe I graphed my thing wrong. Right, 3, -2, 12, -6. I think this checks. Okay. That 10/3 might be wrong. I checked it in my head. Estimate. X equals 8, y equals -4.5. Doesn't seem to work. X is 8. I get 3 and 5/9, -3 and 5/9. Okay. You've got to get -4.5. Got +4/3, and that's my problem. Check, I did make the same mistake. 8/3, 9/3 minus 4/3 is 5/3. I think this should maybe be 5/3. Again, there's why you check. Okay. And now if X is 8. Okay, anyhow. Solve these two equations. Y equals 2x minus 21. Plug that into the second equation, into this. And you get 2x minus 21 equals -4/9 of x plus 1/3. That's an equation you can solve for x, right? So we're just plugging, y equals this and y equals this, then this has to equal this. Then we multiply both sides by 9. We get 18x minus 189 equals -4x plus, which gives us 22x equals 219. Equals 9.95. Okay, now the point is, we can plug whatever we have here for y into y here, right? And get x. Then double check that. That gives us about 20 minus 21 is about -1. That gives me -4 plus 3. It's plausible. Then we plug this value of x into this equation. And we get y equals negative 4/9 of 221 over 22 plus 10/3. Now, if we do the arithmetic, this is practically 10, so that's like negative 40 over 9. And 30 over 9. One. Now, the x equals 8 matches reasonably well with x equals 9.95, but the y equals -1 does not match with this. Okay, so obviously there's an error that we don't have time to correct. But do you see the process here? You have two equations. If one equation tells you what y is, you can plug that in for y in the other equation. You get an equation, you can solve for x, you can plug that x back into one of the equations, and you can get the y value, and the x and the y should give you the crossing. Now, I still don't have the right number on this, and that's the reason they didn't come out close. Okay, if you do it correctly, it works. Quickly, another thing we can do. So I got 2x plus 7, 14. X minus 3y equals 8. Call this equation 1, call this equation 2. If I multiply everything in equation 1 by -2, multiplied by circle 1. Circle 1 means the first equation that we had previously. I get -4x minus 14y equals -28. And my second equation, I'm going to leave the same. Okay. Now, what do you see? I have a -4x here and 4x here. If I add these two equations, x's go away and I just get y. And I'm going to get an equation that I can solve for y. Now, everybody should have seen this. Is this like halfway familiar? I mean, in your prerequisite courses, you would almost certainly have seen this. Okay, anyhow. This gives us -17y equals 20. Y equals -20 over 17. We can take that value and plug it into either of the equations. So I'll just plug it in here, which leads me to the equation 2x plus 7 times -20 over 17 equals -28. I've just replaced this y with this y, with this value of y, and now I have an equation I can easily solve for x. Multiply both sides by 17, I get 34x minus 140. And oh, come on, somebody multiply 17 by 20. Okay, well, it's 512 minus 36, which is 484, I think. Yeah. Big question mark there. I did that in my head too quickly. You get 34x equals -344. X equals -344 over 3. That's pretty big. It's over 100, but I think that's probably, it's over 34. Okay. X is pretty close to -10. Then you can check. Y is about -1. X is about -10. If y is -1, you get -7. If x is -10, you get -20. Would that be negative? Uh-oh. No. It'd be -20. That'd be negative. Somehow it doesn't work, but that's the two, okay? And you'll see examples in the open map. So what I'm gonna do is I'm gonna move the assignment that was due for today. Have it due tomorrow. I think that allows you to go back in and rework some of the stuff. I put a bunch of notes into those assignments. Have you seen some of those notes? Okay, well, you can use those notes, but try not to rely on them, okay? See if you can nail the rest of it. There's some of these things where you have three functions, one function of this interval, one function of this interval, one function of this interval. I wanted to talk about that today. It turned out that we needed to talk more about this stuff. So don't worry too much about that. I'll talk about it next time, or look at the MDE 61 video because we did it there. So we have a question. Let me just